always get ready for the SAC that I would go through some of these practice SACs, and then that way it sort of doubles so you get a solution for them as well. So I might go through one of these per video, maybe see how we go for time and battery. So yeah, let's just get stuck in. So the first one we're talking about, we have a equation. This symbol here, remember, means that this is a direct relationship between y and x. So if we're looking to do that, it means that y is equal to kx, and we're just trying to find the value of k. So y equals something times x. You might be able to figure it out from here, but anyway, the formula for finding it is you just take a y value and divide it by an x value from your table. Doesn't matter which one you choose, so I'm just going to take 10 and 2, and that gives me 5 as an answer, which is that one. Okay. Next one, it says that for the values in the table shown, again, there's a relationship between y and 1 over x. So it's asking for what the relationship there might be. Okay. So if it will help, you can just sort of draw up an extra row onto the table and have 1 over x on there, and that helps me. So 1 over 5, 1/10, 1 over 15, 1 over 20, and that helps me to see the relationship a little bit better. So yeah. So we're looking at this relationship here. There is the formula for it is quite easy. So you can sort of solve it the same way, but because you're dividing by a fraction, I'll save you the long reason as to why, but essentially k just becomes any x value times any y value from your table. All right, or you could do divide by the fraction, which will give you the same thing. So in this case, k is equal to 5 times 3, which is 15. That will work for any of these values here. So 10 times 1.5 is 15, 15 times 1, etc. Alright, and we're doing the same but for squared. So again, it's a direct proportion for squared. So I'm just going to add x squared on the top to help us see it easier. So we got 1, 4, 9, 16, which will help a little bit. So you can sort of see that there is a bit of a pattern here, but we can go back and use this formula. I just realized that that's cut off, isn't it? Let me make a very small adjustment to this camera, which is brand new. Looks good. And I will just rotate this. Whoop, I've gone the wrong way. Okay. Might do it that way instead. Okay. So I've drawn an extra row onto here, and you can use that same formula as before with y over x, except it's y over x squared in this case. So we're looking for our constant k, which is same as 7 over 1, which is 7. And you see that's the same. 28 over 4 is 7. 63 by 9 is 7. 112 divided by 16 is 7. So that's our answer. Alright, so we got through page 1 pretty quick. Let's keep this party going, and I do have a cable on the way too, so just try and move out of your way. Okay. Next one. We have here if A is a direct proportion to B, and we know that A is 12 and that B is 2. What is the value of A when B is equal to 7? Okay, so this tells us that A is equal to K times B, right? We know that A is 12 and B is 2, so I might just swap these around, so 2K. I'm solving for K. In this case, it's 12 divided by 2, which is 6. Okay, so if A is equal to 6B, that means when B is equal to 7, A is equal to 42, because 6 times 7 is 42. Next one. There's a direct relationship between y and 1 over x. Okay, we know that y is equal to 6 when x is equal to 2. So it's the same sort of thing. So y equals k over x. Right? And we know that y is equal to 6 when x is equal to 2. So in this case, if we're solving for k, we times both sides by 2, and that would give us that k has the value of 12. Right? So if k has the value of 12, that means it's y equals 12 over x, which means the value of y when x is equal to 4, so it's 12 divided by 4. The answer should be 3. Okay? Okay, in direct variation, when y and x have a relationship, if the values of x increase, the values of y, they also increase. Because k is not allowed to be negative, otherwise it becomes an inverse problem. So, in the inverse variation, when y is equal to k, if the values of x decrease and the values of y, if the values of x increase and the values of y decrease, because we're dividing by a bigger number. Does that make sense? It doesn't half, because it's not always going to be half. If P has a direct relationship to Q, and P is 40 when Q is 10, which of the following is true? Okay, so if they have a direct relationship, that means that it's P is equal to K times Q, right? And we know that 40 is equal to K times 10, which means K has to equal 4, which means it should be P equals 4Q, which is that one. Okay, complete the 1 over x transformation used to complete the table below. Okay, it's nice and easy. All I'm doing is doing 1 divided by the number above. Simple. Sketch the graph of y against 1 over x and determine whether this graph linearizes the graph. Okay, so these are my 1 over x values. Okay. Sure. So, where do I start from? I suppose it doesn't help that I've done it as fractions rather than decimals, but that's okay. So I think if this is transformed, then we just use our regular values. Anyway, let's just plot these points, see what that looks like. So we've got 2, so we've got a half and 320. So 320 is there, and a half is there. Okay, we've got 170 and 1/5. So that's 120, 140, 160, 170. 1/5 is about there. Okay. We got 120 and 1/10, which is about there. We have 95 and 1/20th, which should be about here. That looks to be a pretty straight line through there, doesn't it? Alright. I would say that yes, it is linear, I guess. Yeah, anyway, you get the idea. Alright, next one. Given the following table of values, sketch the graph of y against x. Okay. So in this case, y is 160, so far out. These are going up by 500s, so It's like halfway through there. 5 and 160, 10 and 610, which is probably, sorry about there. 15 and 1360, that's about there. And 20 and 2410 is about there. So that looks to be a non-linear line. Complete the X transformation. Okay, so I'm just squaring all these numbers. 25, 100, 225, I think is 15, something like that. And 20 should be 400. Oh, my battery's running low. How long have I got? Only a couple more minutes. Let's see if I can finish off this page. Sketching these new values now. So you got 25 and 160. I have 100 and 610. I have 225 and 1360. That's about there. I have 400, 2410. Yes, that looks pretty straight now. Yeah, nice. Yes. So, how long to go on this one? Alright, 2 more questions to go. Alright, hopefully we can get this done before my computer shuts off. Alright, in the manufacturing cost C, one bar stool varies inversely as a square. Okay, so that's like a cost of one of these bar stools varies to the number, so 1 over the number squared. Okay, if 100 bar stools are produced and the cost is $5 per stool, okay, so that's easy. So the cost is $5 per stool, and this is 1 over 100 squared, which is 10,000. So if that's that, so this is K, which means that our K is 50,000, right? So that's our formula there. Find the cost if 500 bar stools are made. I don't know what 500 squared is. 500 times 500 is 250,000. Okay, so C equals 50,000 divided by 250,000. Alright, so that should just be like what, 1 over 5th. The cost should equal 1 over, so 0.2. It's very cheap. Hopefully that's right. Alright, we're looking at proportions of buildings for their heights. So looking at height versus shadow. So height is directly varied to shadow. Okay. So if a 5-story building has a height of 20 meters, so that should be 5 equals K times 20. Is that right? Yeah. I've done that. Oh, I've done that the wrong way around. Sorry, that's 20 equals K times 5, which means that divide by both sides by 5, which means that K is equal to 4. Okay, so each story is essentially 4 meters. So then we're asking if it's how many stories high will a building be? So the height is equal to 4 times 32 meters long. It's a 5-story building. Have I stuffed this up again? I think I have. let me start this again. Okay, so we're looking at the length of building shadows versus their height. Okay, so I've got this the right way around now, I think. So S is equal to K times H, where S is shadow, not story, I gotta remember.